Hello, welcome again. Thank you everyone for joining us this evening. My name is Laura Rossi Garcia. I'm faculty in the School of Design, and this year I'm chairing the School of Design Talk Series. Before we begin, I just want to remind everyone that this event is being recorded. And before I go through the structure for tonight's event and introduce our keynote speaker, I will hand it over to Denise Nakwu, Director of the School of Design, who will say a few words.
Hi, good evening. Good evening, everyone. On behalf of CDM and my colleague Jacob First, Director of the School of Computing, I want to extend my welcome to all of you and to the Bridging AI and UX Student Showcase. It's been our honor to have this opportunity for our students to explore the exciting intersections of artificial intelligence and user experience design fields. This grant would not be possible without the generosity of our two donors. Bold Insight is a full-service UX and human factors research agency specializing in large-scale and global research spanning the entire product development process. We're really grateful for Gavin Liu, Robert Schumacher, and Corey Johnson, who are managing partners, for their support of this initiative. You can find out more about their wonderful company at boldinsight.com. And Leap of Faith Technologies is a digital health informatics company that integrates existing and emerging technologies, high impact content, and strategies to improve patient compliance and healthcare outcomes. Driving their support of this initiative are entrepreneur, scientist, philanthropist Frank Naimi-Rod, and company president, David Haynes. So thank you very much to our donors and welcome everyone.
Thank you, Denise, and thank you again to our donors. We're very excited to celebrate our students' achievements tonight. The Bridging AI and UX grant called for DePaul College of Computing and Digital Media students to propose cutting-edge projects that bridge artificial intelligence and user experience design fields and have a positive cultural or social impact. Tonight, we'll be hearing from three teams, Tweet and Sour, Tips, and Avai, whose members span computer science, creative writing, human-computer interaction, user experience design, data science, and graphic design. Before hearing from our students, we'll open our event with a keynote presentation by Senior Director of Interaction Design and Artificial Intelligence at Anthem Health Platforms, Jofish Kaye. Jofish will be discussing designing opportunities for AI and UX in healthcare. I'd like to share a little bit about the structure for tonight's event. As I mentioned, we'll hear from Jofish, followed by presentations from our students. After each presentation, Jofish will be asking the teams a question. We ask that you either hold your questions or go ahead and post them to the chat for either both Jofish or our students, and we'll open it up at the end for a Q&A for everyone. So with that, I'd like to officially introduce Jofish. Jofish runs research teams to produce thoughtful and ethical HCI and AI products. His research explores the social, cultural, and technological effects of technology on people and how people's decisions, needs, and behaviors can change and improve those technologies. He has served on the ACM Diversity and Inclusion Council, chaired CHI 2016, and has a long-running interest in improving diversity, inclusion, and accessibility. He also has a PhD in information science from Cornell and MS and BS degrees from MIT. So welcome, Jofish, and I will hand it off to you.
Thank you, Laura. Thank you very much for having me. And thank you all of you for coming. I realize this is eating into your dinner time for many of you, and I appreciate you taking the time out. I also appreciate the fact that a whole bunch of you have your cameras on, because giving these talks when it's just sort of a faceless sea of boxes is so hard, because you're like, is anybody reacting? So thank you for those of you who have it on. If you feel like putting yours on, I would be most delighted. But I'm not going to hold it against you if you don't. I understand it. Let me start sharing my screen. All right. Are you seeing a guy on a bicycle?
Yes. Looks great. Yes.
And it's like it's taking up the full screen. It's not some weird thing like that. I'm sorry. It's my first time using Zoom. It's all very, novel to me. Nah, not really. Anyway.
It looks great.
All right, super. And I just need to move this screen a little bit more. All right, I'm going to talk to you today about work at the intersection of AI and UX. As it happens, the work that I'm going to be talking about is in healthcare, but I think the reason that it's going to be relevant and going to be important is that I think that intersection is going to be a defining part of your careers. For those of you who are students right now, and for those of you who are faculty and otherwise engaged, this is going to be the issues that we're going to be engaging with for the rest of our careers, right? I think these really are fundamental in a fundamental way. So let me give you a little bit of the background that brought me here. I got a couple of degrees from MIT, mainly hanging out at a place called the Media Lab. I actually got a master's degree doing computerized smell output. So what you can see there is a little device I built to do computerized scent output to convey information. I think it was about the stock market because that's what we were doing. Everyone was doing stock market stuff back then. It's a bit of a weird thing. But you know, if you smelled mint, then you meant you were making money, like that kind of thing. I went off to Cornell and I did my PhD there as the first graduate student in information science, first graduate student come and do information science there and really try and sort of engage with that as an interdisciplinary enterprise. I went off to Nokia and I picked that particular screenshot there because it was a visualization of how people were talking about Nokia products on Twitter by doing sentiment analysis. And I was sort of delighted to see that that's one of those themes that's come back today in one of the student projects. Around that time, I started doing some work at Stanford. I taught in the D School. I taught the Designing Liberation Technology class there for a while with much more senior folks than me, people like Terry Winograd and Josh Cohen, and that was great. I also taught the Interaction Design Studio class there for a couple of years with some other folks. I chaired the Kaye conference, which is sort of the big computer-human interaction conference, along with Alison Druin, who's now at Pratt. And then I went and I was doing that while I was at Yahoo, and that involved a lot of work across a lot of platforms. Everything from how do people think about passwords and membership to that particular set of numbers that you see there is all about, it was a really bad ad that someone had put on yahoo.com, and we were able to measure how many people saw this ad, and it was so bad that they didn't come back to Yahoo. It turned out about 6% of people were like, no, I'm never coming back ever again. So it was an impressively bad ad. Then I went off to Mozilla. I ran a team there doing things like Firefox Voice, which was think like Alexa, but living in your browser, that kind of thing. And most recently, I've been at Anthem Health Platforms, and that's the stuff that I'm going to talk about today. So there is a question, which is why me and why should I be talking to you and why should you be listening to me? And the answer to that is I want to talk about stuff at the intersection of these three areas, right? I want to be clear, none of this is medical advice. I'm not that kind of doctor. But I'm going to be talking about work at the intersection of all three of these themes, right? We're going to be talking about health, AI, and UX. And one of the things, I know that the people who are on this call are probably interested in those bottom two, the AI and UX. You may or may not be interested in the health stuff. That's fine. But I think it's a valuable thing in this framing of how do we do good in the world with those bottom two, right? With the AI and the UX. And I think you'll find the observations here, I hope, are going to be relevant to other domains, right? Outside of straight up healthcare. Okay, so what we're doing is a thing called HealthOS. HealthOS is a platform. It's a layer. It's an information layer in a platform that lets you share patient data in appropriate ways, right? And by appropriate ways, I mean taking account the fact that there's HIPAA limitations. We need to be careful about who gets to see which bits of data, but also, can you share things like aggregate data, right? If there's information we know about a whole bunch of patients, can we use that to inform what one patient actually does? One aspect of this is creating the idea of a lifetime patient record. something where we actually have some longitudinal sense of someone and their health trajectory. So what I'm going to do is talk about that context of work of the health trajectory and use that. And I'm going to finish up. This is one of those slides that tells you where I'm going to go, right? What I'm going to tell you is that I'm going to suggest these 4 heuristics for AI and UX. I'm going to talk about showing context. I'm going to talking about how it's important to show your work. I'm going to talk about why it's important to respect the expertise of those people that we're talking to. And then I'm going to talk about the need to predict and forecast. Besa, can you hit mute for me, please? Thank you. Looks like we're getting some background noise from you. Okay. Let's talk a little bit about health. And in particular, I'm going to go into slightly more information than you want to know about diabetes. You're just going to have to learn this. It's a good example project. So diabetes is a really big deal, right? About 34 million Americans have diabetes. Of that, 95% of them roughly have type 2 diabetes. To give you an idea of the scale of this, 1/4 of all healthcare spend in the US ends up being connected to diabetes, right? That's huge. This is an enormous amount of money, right? On the clinical side, diabetes is measured by a blood test. There's some blood sugar work that people do on a day-to-day basis, but if you have diabetes, you're probably getting a thing called an HbA1c test about every 3 months, somewhere in there every 3 to 6 months, and it gives you back a number. And that number is a percentage. I'm not going to go into the technical detail of what that percentage means. And to be fair, I'm not sure I really understand what that technically means anyway. But if you are non-diabetic, you've got a percentage there that's below about 5.6. If you're pre-diabetic, it might be 5 point something, 6 point something. And if you have diabetes, then you're going to have a number that's going to be above 6.5, right? It's the clinical definition of what diabetes is. So someone who's got a problem of uncontrolled diabetes might have 9 or 10 or 13 or some number like that. Diabetes is a big deal, right? If you have diabetes, you are far more likely to have problems like blindness, kidney failure, heart disease, stroke, amputation, premature death. Like, it's not a nice disease at all, right? I mean, that sounds sort of spurious to point out, but like, this is really serious. It's not just a matter of saying, oh, okay, maybe you'll be a bit thirstier. Like, it is a serious disease. And that's why there's so much emphasis on this. Okay, that's enough educating about diabetes. I didn't really bring you here to teach you about diabetes. But I did want to talk about what happens when we take that diabetes work and we cross it over with AI. So this is a paper that some colleagues of mine wrote. It's called Causal Deep Learning on Deep Real-World Data Reveals the Comparative Effectiveness of Hypoglycemic Treatments. And this is why nobody asks scientists to name things, because they would end up with names like that. But it does in fact tell you what's going on. What it's talking about is saying we've got people who are Anthem members, right? People who use Anthem Healthcare. Whenever they get a blood test or whenever they get a diagnosis from their doctor or they get a prescription, we get to see that information come in. So we can understand, we can look at correlations between those, right? So that's what they've done in this paper. They looked at a whole bunch of people taking a whole bunch of different diabetes drugs, and we can look at the results. This is a graph that I've taken from that paper. It is not the world's easiest graph to measure. That is the actual caption from the paper. I'll let you read that yourself. And let me sort of break it down a little bit what's going on. So this is all based on people who have an HbA1c above 9%. So we would call that, let's say they've got uncontrolled diabetes. And this is a graph of how much you can expect someone's HbA1c to change between 2 tests. Depending on what combination of drug classes they're on. And those 2 tests, again, would probably be 3 to 6 months apart. So the comparison point, this one down here, this is a drug called metformin. Metformin is pretty much the baseline treatment for diabetes. If you go to your PCP and you say, oh, I've got diabetes, or they say you've got diabetes, this is often the first line treatment. It's very cheap, right? It's about $4 a month. It can sometimes be a bit hard to take, like it's got some unpleasant side effects, which means that not everyone is really happy on it. And as you can see, it's not the most effective of drugs. But it's a good baseline and it's a good thing to compare things to. Now let's go and look at what happens if we add some other drugs in here. So there's about 5 or 6 different drugs altogether that we use to treat diabetes. So for this particular group of patients, and it's not true for every patient, it's not true for everyone out there, but for these patients, which are what we're calling here clinical subgroup 1, so they haven't taken insulin before, they're under age 65, and they don't have that much else wrong with them, right? They don't have a lot of other clinical comorbidities. For those people, it looks like the best drug combination is metformin, along with a thing called an SGLT2 inhibitor, and then another drug called a TZD. The TZD is a kind of old school drug. They're not really prescribed very much. You can see here that they only had 63 people in this particular sample set. But a TZD, it turns out, works directly on insulin resistance. So putting it in there actually makes for a really, really effective way to fix diabetes, right? Even if we add just one drug to that metformin, right, to the metformin down the bottom. So if we just add a GLP-1 agonist or an SGLT2 inhibitor, right, these 2 examples in green, which you can see are much more popular, right? We've got about 1,000 people who did this one. We've got 896 who did the GLP-1. Those are far more effective than metformin all by itself, right? So the problem is, this just took me a couple of minutes to do as fast a job as I could at explaining this graph, right? This graph is meaningful. I don't want to pick on my colleagues in any way. It is meaningful and it contains a large amount of information, but this is not an easy way to think about that data, right? And particularly if you think about when you go to the doctor and how much time they spend in the room with you, they're not going to be looking at graphs of things. They're not going to be looking at displays with different kinds of things like this. We need to present the information to people in a way that's really, really easy to read and really easy to understand. Now, obviously, we're not the first people to talk about this, but I've been surprised at how bad some of these interfaces are. So let's look on the health side. I hope none of you actually build health user interfaces, because I'm about to be rude, because notice that I'm saying that there's no user experience here in this health interface. So I'm probably going to offend some people and I'll apologize in advance. But this is what a typical thing looks like. I took this one from the Virginia Health System. It's an installation of a program called Epic, which is basically the most popular tool for electronic medical record systems. And you can basically see there's a whole bunch of text here, right? You're putting stuff in through this interface that doesn't give you a lot of room for interpretation and for understanding stuff. And I'm kind of being a little unfair here because I'm using this as an example of, oh, isn't this confusing? And I'm not going into the detail. These are systems that are used every day and are used effectively, and I want to be clear about that. But there's still not these opportunities for discovering and exploring. So I've got one more thing I want to talk about. We talked about straight health, right? Now I want to talk about what the straight, sorry, I've got 2 more things, I'm sorry. We talked about straight health. Let's talk about straight AI. Like, what do AI recommendations for this stuff look like? There are, as far as I can tell, something like 30 or 40 different sets of recommendations for making trustworthy and understandable AI models. This is one of them. It's called the tripod checklist. It's pretty good. But again, look at this levels of detail, right? Look at the, they're like, when you're making an AI model, you need to take into account the participants. You need to think about the outcome, the predictors, what data is missing, how big is your sample size, how are you analyzing your methods, what are your risk groups, how did you split your development work and your validation work? All of this, these are really important questions. But I think for most of the people in this room as designers, these aren't going to be the issues that you're dealing with directly, right? I wanted to make something, when I was coming up with the heuristics you're going to be seeing, I wanted to make something that was valuable enough that my designers would print it out and stick it up on the wall, right? So this is very valuable, but again, it's not at that intersection of those 3 things that we're talking about, the AI, the UX, and the health. The other thing that I want to talk about, of course, is just the straight up UX stuff. There are all sorts of guidelines out there. You may well be familiar with Jacob Nielsen's usability heuristics, right? Jacob's been doing this stuff for, I think, longer than I've been alive. He's done great work. His group does great work. This stuff is very important, but again, not quite there at the intersection of all three. So what does those three look like? Let's dive in. Let's have a little look at that. Let's talk about the first one, which is context. So I want you to have a look at the two examples, the two little bits of a medical interface here on the left. This is pretty typical, right? This particular patient has an HbA1c of 9.8, right? They have a creatinine level of 1.42. Their LDL is actually not bad. It's a bit 118, right? But look at that 9.8. 9.8 by itself is not a good HbA1c. If you went to your doctor and they said, oh, you've got 9.8, that's a problem. But then look at this example here, right? Here we put in a spark line. That's a data interface element that Tufte came up with, what, 15 years ago now, something like that. That spark line tells us that this 9.8 here, it used to be higher. Actually, that's looking better, right? Things are sort of improving. It might be flattening out a bit, depending on what the time scale is here. But that idea that we can start to put information in context, right? And that's this key thing, that when we're informed by big data, we can show not just about this is about showing the context of the individual, right? Like, let's show their own data in the context of their own data. If we look at the thing on the right, you can see something, this is more about showing the patient's data in the context of the big data that is available to us through this system. Doesn't particularly matter what this is. It's a measure of cholesterol as it happens, and it talks about the hazard ratio and the relationship. I can then take a particular instance and I say, well, okay, if I've got if I have a particular point on this graph, and whether this is the right example or not, we'll let go. I can say, this person is exceptional. Something is going off here. It looks like we've got a problem. Things are not as clear as they should be. We need to understand this a little bit more, right? So showing the context, I mean two things. Show the context of the patient's own data and show the context of the larger data that is available, because that's the new thing we're able to do here. The second thing is show your work. This ties, if anything, more to the AI guidelines that we saw earlier, right? Can we show the things that are going on? So this is a different particular project. This is about being able to predict the probability of hospital admission. This I took straight from some work that my data team did. You can see, and that's why I think the interface is maybe not as good as it should be. But what they're saying is that for this particular patient, the baseline is a 3% probability, a 3.6% probability of hospital admission, right? So if you know, whatever age this person is, 72, in general, we'd expect them to have a 3% chance of going into hospital in the next, I think it's 2 years, something like that, 6 years, 6 months, 2 years, I forget what number we settled on for this particular data point. But then you can see all these factors that add up, right? Notably, they've just had an inpatient admission for something about their heart. They have a diagnosis for heart-related things that points out they're acute. They have problems with peripheral vascular disorder. They've got diabetes, et cetera, et cetera. All these components make things worse. The fact that they're 72 actually turns out to be an advantage compared to other people for this baseline patient. But that idea that we can show the work of this is how the AI model has made this prediction that this particular patient has a 71.4% chance of going to hospital, we need to be concerned about them. The third one is, if that one was more on the AIS side, this one is more on the UX side, and that's about respecting the expertise of the people who are using the system. And I think this is particularly true for healthcare, but in general, we forget the fact that in big data systems, we have a limited amount of information available to us. If you think about how much information is available to me as a person just looking at a stream of data, it's going to be so much smaller than the doctor sitting in front of someone who's able to ask questions, can hear their voice, can tell if they're slurring, can look at the color of their face and say, well, okay, you're looking like you're a bit sick. Maybe they know that patient from earlier and they're like, well, it looks, you don't look as healthy as you normally do. And that kind of contextual stuff is very important. So how can we use the data that we've got for these data-driven systems to provide insights that still respect the expertise? The first draft of these systems always ends up looking like this. Patient has high blood pressure. We recommend a beta blocker, right? That doesn't tell them anything. Doctors went to doctor school for a very, very long time. So they know things like, yes, they've got high blood pressure. They should have a beta blocker. But can we say things like, 82% of doctors prescribed a beta blocker, or possibly 82% of doctors like you, right? Doctors who have a similar background or patients like you. Are we able to say things like an ACE inhibitor might be a better choice here, right? Again, how can we respect the expertise of the people we're engaging with rather than assume that we should tell them the basic things? I want to be clear about this one in particular. I made this thing up, right, about the ACE inhibitors working 8% better. It's just not true. Again, not that kind of doctor. But it gives you an idea of the kind of recommendations. All right, one more, then I'm going to wrap up. The key thing we can do with data-driven systems, particularly when we're thinking about the UX experience of those data-driven systems, is to be able to predict and forecast, right? Here's a patient. This is a measure of their blood lipids, right? Like their cholesterol, things like that over time. We can see that at the beginning of the year, they went on rosuvastatin, which is it's a pretty standard statin, Crestor. I think it's Crestor. And you can see that it had a pretty good effect on them. And we can predict, okay, this is what's going to happen with this patient's various, their triglycerides, their HDL, if this continues. We can do things like this on the right. So this goes back to the diabetes example. If they just remain on the blue treatment here, which I think is metformin, then their HbA1c will end up somewhere in this cone after their next test. However, if they switch to the TZD, then we think it'll end up in this thing here. I don't love this particular display. It does show the uncertainty in the predictions, but it doesn't very clearly show the relative probability of those. But it does point out this idea that we want to be able to predict and forecast stuff. So this is not everything, right? There is so much that we could say and so much more that we could do. But I wanted to give you something that you could take away from you, something that you can put in the back of your head that was small enough that you could actually remember it. You're like, oh, he said 4 things: context, show your work, respect expertise, predict and forecast, right? For the students on this, I really do think this is going to be a career-long goal. If you think about what designers were facing 40 years ago, right? The world was changing and they were going to be spending the rest of their careers designing interfaces that use computers in some way. You're going to be designing interfaces that use AI and data-driven insights, although the names for those are going to change over the course of your career. And that's going to be a huge part of your roles in that world. I think that's a really exciting thing. I think it's a really inspiring moment. And that's why I'm quite so excited to be here. So thank you very much for having me. It's been a pleasure, and I'm happy to take any questions that anyone might have. Thank you.
Always takes me a second to unmute. Thank you, Jofish, so much. That was fantastic. I feel like I'm absorbing and learning. That was really great. I'm going to go ahead and introduce our first team. If anyone has questions for Jofish, feel free to start putting them in the chat. I can gather them and read them out loud at the end, or we can hang on to them and we can, you are welcome to unmute at the end and we'll share them that way. All right, so our first student team tonight is, their project is titled Tweet and Sour. This team is composed of computer science students Chip Davis and Jonathan Mikulak, and Danish Raj, along with creative writing student Emma Ludman. Their project takes the form of a Twitter bot that performs sentiment and other forms of analysis on tweet replies. In an era where misleading news and bot accounts are so prevalent, a tool like Tweet and Sour can help give broader insight to Twitter users based on examination into larger conversations surrounding a tweet. So I'll hand it off to Tweet and Sour.
Thank you so much. Give me just one moment to share my screen and then we'll get started.
Okay. Welcome all. Thanks for being here. My name is Dinesh Raj, along with Chip Davis, Emma Ludman, and John Mikulak. We make up Tweet and Sour. Our advisor is the incredible Professor Hastings, or as we know him, Mr. Peabody. We are a project aiming to augment the user experience on Twitter by delivering comprehensive analytics about the public reception of a tweet by analyzing the sentiment of the aggregate replies. The modern manifestation of a newspaper headline is a tweet. Breaking news no longer waits for editorial approval or physical distribution, making news ranging from the death of Prince to the progression of a deadly virus break on Twitter first. However, the headlines we consume on Twitter are uniquely different from those of old media. Rather than 24-point Times New Roman or a newscaster being the only insight to a topic, Twitter offers the opinions of thousands of people directly below groundbreaking headlines in the form of replies. Now, this is inherently a paradoxical situation, right? On one hand, replies offer more information than ever before. Data about their public response to cultural happenings would be unthinkable in the past, especially on the scale that Twitter offers. However, humans are physically incapable to carry out the cognitive analysis necessary to gather any meaningful interpretation about the stream of data. Tweet and Sour aims to bridge this gap, allow users to holistically and thoughtfully consume the incredible volume of data they're expected to handle while breaking their reliance on Twitter's reply ranking algorithm and their own personal echo chamber of public perception.
All right, so as Dee was talking about, one of the biggest social impacts that we see our project will give is it allows the users to be more informed about the content they're consuming. Twitter's algorithm for the top replies shown are not always indicative of the actual sentiment surrounding the tweet. Feed bias is something that's incredibly easy trap to fall into. And often the top few replies are used to gauge the public opinion. But in reality, there are thousands of replies that can tell a different story. But we don't see this as the end user's fault. It is impossible to read every single reply to every single tweet you come across, which is where Tweet and Sour comes in. Hopefully, it will encourage people to think more critically about the information they read on Twitter.
In recent years, more and more people are relying on Twitter as a source for breaking news. So by having a feature that will allow them to sort through the replies, they will be able to examine the media they are consuming with a more thoughtful eye. The current Twitter algorithm curates a hyperspecific feed based on the user's personal preferences, which can leave them with a very skewed perception of public opinion. The goal of this project was to free the user from Twitter's ranking algorithms, and which will give them a more insightful view. In the early stages of this project, we wanted to make sure that we were creating something that would really fit users' preferences. So we decided to send out a pre-designed survey to a pool of 34 prior users. Based on the survey, we found that 94% of responders were using the Twitter app over the website version. 82% responded that they rarely had time to look through all of the replies to a tweet, which kind of confirmed that our project would be useful. And then 88% of people were interested in an interactive bot feature to let them know more analysis beyond the original positive and negative that we were able to provide. As a result of that survey, we realized that we needed to pivot away from the Google Chrome extension and move towards a Twitter bot to better serve the mobile users. So we sent out a series of 3 different mock-ups, each with a different tone, a different graph style, and different presentation. And based on the survey, we found that responders preferred a bot with a more casual tone. We were able to find the correct graph based on user preferences and just the correct reply style for our project.
So as Emma just mentioned, our project actually started out as a Google Chrome extension. One of the biggest things that we learned while doing the surveys was that we are not the end user. While we imagined Tweet and Sour as a Google Chrome extension, that was mainly because we are all developers who tend to see things through a more technical eye. We thought it would offer the best user experience by integrating directly into Twitter's webpage. But as the survey showed, 92% of people weren't even using Twitter on their computer. So that would alienate every single one of those users. So that's why we decided we had to pivot to creating a Twitter bot. But we actually think this is a better user experience as it allows users from any platform or device to access Tweet and Sour. And we're able to reach users very organically through the timeline. We hope by giving it an engaging and interactive personality, it will encourage the users to keep coming back.
Yeah, so the initial form of sentiment analysis we were performing was through a library called Aphin. After running manual tests and validating scores returned by Aphin, we realized there was a major issue with it. Aphin worked incredibly well for directly toned tweets, those that read professionally and more like a New York Times article. This was an obvious issue, as anyone who's used Twitter would know, because tweets are rarely in the professional tone of articles. In our search for a more applicable sentiment analysis library, we found Vader, a library that performed particularly well on tweets. Now, in a study published by Georgia Tech, Vader not only outperformed other popular sentiment analysis libraries in classifying tweets into positive, negative, or neutral, but also strongly outperformed humans. This study assigned a true sentiment score to a large set of tweets and tested how closely a variety of sentiment libraries got to matching the true score. The experiment was run on 7 additional sentiment libraries, Vader, and a set of human individuals. The best of the 7 additional libraries scored 0.77 in a correlation coefficient to the ground truth. Humans scored 0.84 and Vader scored 0.96. The accuracy in formulating the sentiment of natural language, particularly tweets, was stunning, and is the reason we use Vader to run all of our sentiment analysis. Now, given that this is our primary output to users, we are always looking for ways to improve. Vader being a free, open source, and academically recognized library, we are confident in its ability. However, this summer, we also received a private and exclusive key to the most advanced natural language model in the world, GPT-3. We will expand on our plans to use this in our conclusion.
And yeah, so we're gonna give a little demo here. This is just a screen recording. And here, wait, could you pause one sec, Chip? Can you pause and go back? Yeah, this is just a screen recording of 2 ways that you can interact with our bot. So one, you can send the tweet that you would like to analyze the replies from via direct message, or you can just mention. And so if you start it now, Chip, I'm gonna kind of try to walk you through this. It's a little quick, but so first we're gonna send a tweet from SportsCenter to the Tweet and Sour bot. And then we're gonna find another tweet on SportsCenter and just tag it. So we'll reply at Tweet and Sour bot. And then we'll go back and check out the DM that we just requested. So there's the results from that first tweet, and you get, the next page will show kind of the graph that we returned. And then here's our mention. And so this was the time that we tagged the bot. So that's 2 different tweets, simultaneous pretty much. And then if we go to the next slide, this is what the user will get back. So they'll get the original tweet up top, who tweeted it with the profile picture, and then a pie chart of how many tweets were negative, how many tweets were positive, how many were neutral, and then our sample size. The sample size will be slightly smaller than the total amount of tweets because we're cleaning for like duplicate tweets or tweets that don't have any content viable for sentiment analysis. Yeah, and then we just have some future goals. So like Dinesh was talking about, using GPT-3 would improve our accuracy significantly in our just manual testing. That's what we've seen. And then we also hope to design some more prompts for GPT-3 that could give us more classifications aside from just positive, negative, neutral. And then other things that we want to focus on are improving our UX. So we always want to focus on making our responses as human as possible. And then we want to listen to users and improve from their feedback. And reach out to them. If we have someone that's using it a bunch, we want to reach out to them, keep getting feedback from them. And then we want to add commands, sort of kind of like a way where if you tag the bot or sent them a tweet, you could include a piece of text that would let the bot know you want to see a different type of analysis or a different chart or a different something else like that. And then this kind of ties into, we want to do other forms of analysis / data visualizations. One form of analysis that we already have pretty much ready to go is a weighted style. So that chart that you just saw on the last slide, it takes, those percentages are just how many positive replies there were out of all of the tweets. But a weighted analysis would mean that those percentages would be calculated by how positive or how negative the tweets are. So our analysis actually gives us back a compound score from, say, -1 to 1, -1 being extremely negative, 1 being extremely positive. So a weighted chart would maybe give another insight into how positive people really are replying to this, how negative they're applying to that. And then other data visualizations we've talked about are standard things like a histogram or stuff like that. But those, we could see interesting distributions with maybe a lot of people replied slightly positive, and then there's a huge spike of people that replied extremely positive, and that might be something that users also want to see. And I think that's it.
Yeah, and then before we get to questions, we just wanted to say thank you to Professor Hastings for all of his support on this project.
Yep, and this is also all of our contact information if anyone wants to give us questions. And we also encourage you, after the entire presentation is done, after everyone has presented their project, please go try to interact with our bot and email us if you run into any problems. So thank you guys so much.
Thank you all very much. That was super to see. And I love that in your presentation, you went through the process of trying things, of doing things like realizing, oh, wait, not everybody is like us. Like we can't just install this Chrome extension, right? So I like to see that path. And I like to see that you thought and rethought about who you're trying to talk to and what you're trying to do with this. I want to go back to some of the work you were talking about at the very beginning, right? About combating Twitter's algorithmic bias and encouraging critical thinking. And the paper that and I'm sorry, I have enough of an academic in me that I still think of in terms of the paper. The paper that I kept thinking of is pretty classic. It's Langdon Winner's paper on which is called "All Artifacts Have Politics," right? And what it talks about is that there's no such thing as a neutral piece of technology, right? This is a classic in the science and technology studies world, right? And in more of the critical kind of design world. And I think Twitter is particularly an interesting place to think about this, because there's an argument that is there such a thing as a neutral tweet, politically speaking? I can argue, like I can agree entirely from a sentiment analysis point of view, but if you're trying to think about the algorithmic bias that's inherent in Twitter, and then the question is, well, what do you do about that as a designer? As a designer, how do you think about engaging with that? And I think it is interesting to think, what would it mean to make a really opinionated bot, right? So you can imagine thinking, well, what if we had a bot that really thought that the most important thing was that we should all be more positive in the world, right? Well, that's a sort of an easy extension from the work that you've already done there, right? You can imagine taking that sentiment analysis and then being able to pull out what, the most positive responses to that. And it's trivial to think about what a negative bot might be. But the question that I have for you is, if you are replacing Twitter's existing algorithmic bias, which exists, right? I'm not denying that in any way. What are you replacing that algorithmic bias with in your bot, and what would you like to replace that with?
Yeah, so I think one of the biggest things that we see wrong with the feed bias is those top few replies to the tweet, right? Those aren't always necessarily true about what everyone else is saying. So that feed bias could be putting stuff that you personally agree with or you personally disagree with. It could be either. because that feed bias and that algorithm is just trying to get you to interact with Twitter as long as possible. So we're hoping that with our tool, you'll be able to get more information instead of just those top few replies. And if anyone else on the team wants to add anything, feel free.
Yeah, I think what you're saying is like really interesting, because I don't think that there is a best way to just rank the replies. I see this project as more of like a call to show people that, you know, these platforms need to be offering more aggregate data about what people are thinking, because it's an impossible problem, right? How are you going to give users these 3 replies that are somehow not biased at all? Like, there's just no way to do that. So I would say like the solution to that would be to just offer them more holistic data, because they have the tools to do that, right? They have the tools to give people a better idea of what is going on in these tweets, under these tweets, how it's impacting the rest of Twitter. But we don't have access to that. And I think that's why like this bot is so important and so powerful, is because it's the first like holistic data aggregation thing I've seen on Twitter that people can use, that just regular users can use. But yeah.
So I want to push you on that question. What would it mean to, what would you be replacing the existing algorithm with? Like whose tweets, or what is the qualities of the tweets that you feel would be most important to raise up that currently are not being featured by the existing algorithm?
Yeah, I would like to say I think the target tweets for this are kind of any tweet that has more than 500 replies or 1,000 replies, or, you know, tweets from big public figures, because there is a specific ranking that Twitter will put them in, but beyond that, people might read 100 replies from a big public figure, but there's no way they can read 15,000 or 10,000 or something like that. So I think it's not necessarily to do away with Twitter's algorithm, but I think it's more of like a way that, you know, maybe a big public figure tweets something and the first 5 replies that Twitter puts up there are very negative, very combative, and the next 3,000 of them are very positive and very like joyful, and maybe you only decided to read those first 5 replies, and so then you left with that taste in your mouth and didn't understand that, oh, actually 75% of these 15,000 replies were actually very positive. And yeah, so
I should frame this. I'm asking, this is not an easy question,
okay,
right? Like if I wanted to ask an easy question, I would have been like, tell me why you made it on dark mode. It's such a nice colors you chose, right? Like I'm deliberately asking the questions that are hard and that there aren't easy answers to them. So you're giving good answers, and I should frame that with that to begin, right? But I think the question then comes, what is the responsibility of you as designers building these algorithmic things? Like, to whom are you responsible? Like, who do you want to think about as your users of this? And what is it that you want to give them? So I want to go back to the 4 heuristics that I threw at you, right? One of the things that's interesting is that Twitter users are in many ways experts at what they're doing, right? Not everybody, obviously, right? But if you think of, you know, your 10,000 hours of practice, there are people who have spent 10,000 hours on Twitter, right? Whether that's a valid metric of expertise or not. Can you think about ways that you can use what you've got there to predict things like trends, right? Is the normal response, and I don't know this, I'm going to make something up, to any tweet that SportsCenter does, people initially are very, very negative, initially very negative, and then if you look at the long tail, in fact, people are way more positive, right? Or is that, you know, does everybody hate anything with the Buffalo Bills, but people really like the Red Sox, right? Whatever the random, whatever that turns out to be. So can you use the amount of information that you have available to you? I mean, I love the idea of here's the split of opinions in responding to that. Like, I think that's a fabulous idea. I just wonder how you can provide a little bit more information for the expert users that we have of Twitter.
Yeah, so one thing that we've actually thought about is maybe not measuring like, oh, they love the Red Sox and they hate the Buffalo Bills, but we've thought about kind of establishing some type of baseline for the Buffalo Bills. So you would do kind of this split of opinion that we already have, but you do that for every Buffalo Bills tweet. And then, 100 tweets down the line, you'll be like, oh, well, the users are responding, maybe the split of opinion is very similar, but the users are responding 20% more positive to this tweet than they normally do to just the Buffalo Bills. If that makes sense. So say on average, so say on average the replies are 30% positive to Buffalo Bills, and then this one happens to be, so like that would indicate kind of like trends, like you're saying, oh, like maybe SportsCenter's getting better at being a social media account, and they're on this uptrend of they're getting more like positive feedback from people or more stuff like that. We've also thought about ways that we can take this data and maybe like marketers can kind of get a grasp or get maybe a second opinion on like how they're doing, because a lot of marketing like advertisement metrics are like click-through rate and impressions and stuff like that, like very crude stuff like that. And so maybe they could get a second opinion with something like sentiment to be like, oh, was that a good tweet that I just posted for the Wendy's account or whatever, something like that.
I love all of this.
I'm not sure if that.
Sorry to interrupt. I love all of this conversation, and I love all of the questions that are coming out of this. I'm gonna keep us on the agenda and move us on to the next group. But I see also lots of great questions and thoughts and responses coming in the chat out of this discussion. So let's go back to it at the Q&A for sure, definitely. And I also want to say congratulations again to Gene Sauer. Thank you for such a great presentation.
Thank you.
So I am going to introduce our next team, TIPS. This team is comprised of data science students Lin Wan and Haoyu Lu, along with graphic design student Hannah Tesfaye and user experience design student Lily Newbold. They developed a project that illustrates what can be achieved when design meets science and tech for the purposes of travel. So I'll pass it on to them.
All right. Thank you, Laura. What happens when you combine travel, data science, design, and implement a client-centered approach to every aspect of a company? Tips. We aim to be a secure one-stop global travel and social hub for underrepresented groups, define an unbiased travel data, community, and promote self-expression when traveling. I am Hannah, the graphic designer. We also have Lily as our UX designer, and Haoyu and Lynn as our data scientists. Here is a quick overview of our presentation today. I'm sure you're wondering, what makes TIPS unique? Why is it that we are so much better than any TripAdvisor that exists right now? Our answer comes in the form of 4 core pillars. We are the only platform that combines convenience, security, accessibility, community seamlessly in one easy-to-use, personalized interface. We take the work and hassle out of traveling, leaving the user with a one-of-a-kind experience that can't be matched elsewhere. Next, I'll show a quick overview of what our style guide looks like in the formulation of our logo and our AI assistant, Sky. This, in summary, is the foundation of the design aspect of our website. Now, I'll hand it off to Haoyu and Lynn to explain the role that data has on our website.
Thank you, Hannah. Hello, everyone. My name is Lynn. I'm gonna talk about how our website different from other travel websites, since we pay more attention about our security. Of course, we are not only care about your physical safety, but also your privacy. As we know, there are many different dangerous conditions traveler may be involved, such as some nature disaster and man-made dangers. Therefore, our website wants to give our users as much relating the information as they want, so they can plan ahead and get a chance to avoid dangerous situations. Based on our research and analysis, we collect different data sets from different official city department portals. By embedding the Tableau interaction dashboards, our users can select different dashboards to obtain the information about the destination, such as some traffic data, public health department data, and the landmarks data, and so on. Dashboards is a kind of convenient and straightforward way to put all the useful information together and show to our users. I'll show you 2 examples about our dashboards of our first destination, Chicago. So first, we just need to select the data of the dashboard. Here I selected Chicago crime data in last 5 years. And on the screen, we can see a map is showing some spots which are one type of crime happened in July 2021. So by using the filter of date and the crime type, our users can get some general ideas about the booking hotels or choice of landmarks. And the next page, the dashboard is about the most events or activities will be held in Chicago. Therefore, our users can get all the information they need, such as the events or the activities website, date, and others. Then our users can make a perfect plan of what they can do in the Chicago. On the other hand, the weather is always unpredictable. And as I mentioned before, we always want our users to have the best plan and stay safe. So we generated some prediction models, such as the weather condition prediction model. Now I will pass to Hao-Yu to introduce our weather prediction model.
Thank you, Lin. Hello, everyone. I am Hao-Yu, and I will show you an example of our AI and machine learning model about the prediction of weather condition. So from this detailed weather data of Chicago from 2008 to 2021, which we have conditions like blizzard, blowing snow, sunny, and so on. So we have built more than 10 models, including random forests, SVM, deep neural networks, and so on. Our models are tuned with tenfold cross-validation, and we use the grid search to tune the model and try to find the best parameters for the model. As a result, random forest gave us the best prediction accuracy of 92%. Then, in order to make an overall view of the weather, we combine the weather conditions into 4 categories. They are bad weather, cloudy or fog, moderate, and sunny. Therefore, we will collect the events dashboards as shown before to recommend safe for outdoor events for sunny days and not safe for outdoor events, but good for indoor, such as museums, for bad weather days. We also build models for other security and travel-related data, such as crime rate and tax trips, which will provide more customized suggestions for our users. For our future work, we have already made onboarding quizzes and demographic survey in order to collect the users' data in our own database, which Lily will show you the quizzes later. After we finally set up our website and have enough users to fill our quizzes, we will be able to build our own database on AWS Cloud, and our personal assistant Sky will pass the collected data to AWS. And then our recommendation system will recommend activities from different perspectives, such as safety, which Sky will interact and pass the recommendations to our users. Most importantly, we will automatically provide personalized recommendations and dashboards for our users based on their own preference. Then I'll pass to Lily to introduce our user experience design.
Thank you, Hao-Yu. Jack is a representation of our target audience. Here's his persona for you to read over. Some highlights include he's African American in his early 30s, and his pronouns are he, him, they, them. Now I'll walk you through our landing page features, signing in, our user dashboard, and our personalization quiz. If you click the overlay in the top right, you can see exactly what our site does. Sky is in the lower right middle, and this way takes you to the planning of your trip. So let's walk through signing in as Jack. type in our name, password, which is hidden, sign in, and this is Jack's customized dashboard. Using data collected by our AI Sky, here's the weather, events, and an inbox feature for Jack to stay in contact with travelers he's met abroad. For better personalization, one can take our quiz. Since security is a pillar of our site, the terms and condition also covers where your data goes. We do not sell your data. Sky just collects it, making our site the source of data for underrepresented groups, which will help with negating bias that usually caters to more represented groups. We'll go ahead and fill out the minimal information. There's also signifiers, the green check showing that you've completed the task. The quiz starts with less sensitive questions, such as how often do you use a travel site when making vacation plans? And ends with more sensitive questions, such as when you travel internationally, how important is cultural diversity when choosing a vacation destination? Thank you for taking our quiz, and I'll hand it back to Hannah to talk about the design and UX.
Thank you, Lily. We mentioned that accessibility is one of our core values, so I'll show you two of our most popular ones. So there's a feature up here that shows you the day and night mode. Here we'll go to who we are, and I'll demonstrate that really quickly. We're on the night mode right now, and you can get to day mode by clicking on this and back and forth as you please. The next mode, or the next accessibility feature I talk about, is Sky, who is our AI assistant. She can help navigate the website and answer any questions that you might have. Sky is voiced by a Black woman and offers voices of underrepresented communities. The next page I would like to show is the Connect page, which you can find and build a community at. The community page is divided into review, Q&A forum, and gallery. The review page allows guests to rate trips, whether it was through the TIPS website or not. And this allows other guests to then filter by location and read reviews of a place they had in mind. I'll show that now. So here we have continent, and we'll do North America. Country will go with United States, state will go with Illinois, and for city we'll leave it at all so that you can see there's some Naperville, Chicago, and so on. Here, if you want to read more, you can click on read more, which then expands what this 85% is based off of. It expands the comment, allows you to report, block, or add the user and see the images at a larger scale. Now let's go to the Q&A page. Here is where anyone can ask questions to the TIPS community. For example, this guest is asking, where are some places y'all have traveled to that felt safe as a person of color? If you find that question interesting, or you have the same question, you can click on it and it expands to this large page that allows people to have communication, discussions, and ask more questions if it is related. The next page I want to talk about is gallery. The gallery is where our guests get visually inspired. You can again filter these by location and expand them by clicking these little plus signs so that you can see comments, make comments, or you can also like the photo. So TIP is committed to giving you the most comfortable, easy, and secure, enjoyable experience. Thank you for listening. I'll offer you this recap page of while you gather your thoughts and questions. We enjoyed having you here, and I hope you enjoyed our presentation. Thank you.
Thank you, Hannah. Thank you, all of you. I have, let me start off with, so first off, I really like the emphasis there on doing data-driven experiences and looking at ways to make that happen. One of the questions that I have, and this is a question that is true, I think, across nearly everything that involves sort of dealing with consumers on a day-to-day basis, is how would you get over the blank slate problem? Like if we were going to take this out and say, look, this is a really unique concept. And by the blank slate problem, I mean, it's precisely the problem that we're illustrated here, right? You're like, we have these reviews, but they're all full of lorem ipsum. How would you be able to bootstrap this so that your first users would be able to hit the ground running with content in there?
Well, if I understand your question correctly, I think this is currently in the prototype phase, so it's on Figma. we would then have to build it out and then allow users a small case study or a small group to then test it out so that we can see real live comments. But as of right now, because it's in the prototype phase, it is we are using LormSum.
Sure. No, and I understand that, right? Like, and I'm not. No one's expecting you in the course of this to sort of have done all of that. But it is still a question sort of in the back of your head, right? How would you actually launch this if were you to want to move this to the next stage? That's the question. The other question that I have, and I want to sort of I want to ask, I guess, someone from the data science side and then someone from the UX or design side this question. I'm thinking about that initial visualization, which I understand is not something that would be part of the website, about crime in Chicago, right? Which seemed to show that all of Chicago had roughly uniform crime levels, sort of in that sort of Chicagoland area, right? Like it was sort of light blue across the whole area. At the same time, I really liked the question that you brought up at the end, the question of a place I felt safe as a person of color, right? And again, I think it's a super important question. How do you reconcile those two parts of these two kinds of information, right? Because on one hand, we have some information which is just sort of generic crime data. And then we have this sort of very specific persona, which is asking a very important, very valid question. So I'd like to ask you, in the course of developing this, how did those conversations go between those two parts of the team?
Thank you for this question. This is a very good question, and we really pay attention to our users' safety. So, for example, for this Chicago's crime data, we just show the dashboards of like what's happening in this area and what type of the crime it is. But actually, we have done a model for the crime, which we have select the different kinds of crime and show like what's the highest possible time that this crime happens. For example, if I didn't remember this one, the highest crime rate in Chicago is robbery and theft. So and the most frequent time is the New Year Eve, which is January 1st every year. So like if users choose, they will travel to Chicago and the date of the travel will be January, we will have a warning showing that during this period, there are some like highly possible happening theft or robbery, which in different like loop area or Naperville, which will remind them that they have to take care of this situation. So we will apply this models to other cities or other countries. So when users choose the specific time and specific area, they will receive the warning message, which hopefully help them to improve their tension for the safety problem.
Yeah, thank you, Haoyu. Yeah, I just want to add some more details about these parts. So we already have some more about the crime data side from different cities in the United States, but for different cities, they may have the different situations about the model or prediction model parts. So maybe we can set up one baseline for the prediction models, and we can do the compare with others, and we can do like the tune the hyperparameters or something like that to adjust our models. Yeah.
And if I could also add really quickly, the design part really dealt with comforting people and giving security in terms of the human aspect and the subjective aspect, whereas the data is the objective aspect, and you can't just have one without the other. We find comfort and security in other people and what other people are saying, as you do when you're looking at Amazon reviews. So that is why that community aspect is really important. You can't just have just objective data and feel secure. And so that's why we do that duality of having both at the same time.
I'm gonna step in again. Sorry to interrupt the conversation, and I see Flo in the chat as well. The chat is very active, so everyone make sure you keep an eye on the chat. Thank you to Jofish for such great questions. Congratulations, Tip, for such a great presentation and for the discussion afterwards. And I'll introduce now our last but not least, our last team, Avai. Is comprised of digital communication and media arts students, Victoria Lopez, human computer interaction student, Peace Win, and user experience design student, Daniel Mitev. They developed Avai, an autonomous vehicle infrastructure communication solution.
Thank you so much for introducing us. Also, thank you everyone for hanging in and joining us this evening. We appreciate it. So we're Avai. I'm Victoria.
And I'm Peace. It will just be us two today, but joining us in the audience is our awesome mentor, Ilyas Woodson.
And we're solving for the future roads of Chicago. Let me highlight the word future because our solution is speculative, but it's inspired by current events on Chicago streets today. So we're going to be covering a lot this evening, and we're going to be talking about the challenges with communication conflicts between vehicles and bikes. We're going to talk about our research where we did observations and talked to Chicago residents, our solutions where they're going to be based around AI-powered communications, and our future steps, what the future could look like with autonomous vehicles. So with talking about challenges, safety and communication is important with a large city and such a dense population, like with 2.7 million people. So ensuring safety for such a large population, it's top priority to keep the roads safe. Top priority because the National Highway Traffic Safety Administration has stated that accidents between vehicles and bikes have been on a rise in large cities. And even during 2020, we saw a 7% increase in bicycle fatalities and accidents with vehicles. So we asked, how can technology help in the future? Let me introduce you to Avai. I just want to put in some suspense for everybody. Lots of suspense. So I want to talk a little bit more about autonomous vehicles. They're not just going to come in and swarm our roads overnight. There is going to be this awkward time of mixed vehicle traffic between autonomous vehicles, human-driven vehicles, and pedestrians, all sharing and navigating the same streets. And we're starting to see this integration now with different levels of vehicle automation. We're seeing it with Tesla's level 1 to 2 advanced driver assistance system called Autopilot, with Mobileye's level 4 to 5 robotaxis in New York, and Waymo's 4 to 5 robotaxis in Arizona. So we're going to have challenges to overcome. When the public perceives AI negatively and doesn't trust technology, we're going to have a hard time introducing it into our communities, especially when it involves pedestrians that don't have that inherent protection of being inside of a vehicle. And this is where our research really takes anchor. From our research, we learned that bicyclists can be the most unpredictable, but also the most vulnerable agents on the road. So with our limited time, we focused on a very specific future problem. How can bicyclists and autonomous CTA buses safely and confidently communicate on Chicago's streets? A simple answer, some may think, is to have a vehicle that clearly and obviously shows that it sees you. So Jaguar Land Rover did testing around this, and they found that participants were saying that it was creepy, they felt uneasy crossing in front of the vehicle with these large googly eyes. And so
So we explored this, and to understand this problem space a bit deeper, we conducted 6 Chicago resident interviews and 3 industry expert interviews. We then went into the environment at different times of the day to watch and understand the problems. The most dangerous times are the morning and evenings during the golden hours. In photo number 1, you see a driver not noticing an incoming bicyclist, therefore opening their door into their path. And beside that, there is a bicyclist riding past a stop sign. In our data collected from our interviews, the participants expressed that bicyclists make unpredictable decisions when on the road, and that road infrastructure needs technological improvements for future interconnected vehicles and pedestrian communications.
An insight that we took away from this research was we wanted to solve that simple communication that many of us take for granted. Waving to others to go ahead and proceed, or that second nature to glance to get confidence from that other driver or that bicyclist about to cross into the street. So our initial idea was to research a solution for personally owned autonomous vehicles, but learning that there was over 1 million registered vehicles in Chicago, we were quickly overwhelmed. So we narrowed our focus to a vehicle that encounters bicyclists most often and at those dangerous times of the day, Chicago buses. Our solution for the future is autonomous CTA buses that see bicyclists and can predict their future paths. But to have a bus that can tell the future, we need to have smart AI and lots of data. So we would start with training our AI from the suggested safety hand signals that are recommended to all bicyclists. However, knowing that a lot of bicyclists don't use these, we would take a page from Tesla's shadow mode and we would partner with Divi to collect data right from the source, Chicago bicyclists. Now, knowing that training our predictive AI based just off images and Divi collected data alone would take hundreds of hours, we would work with Cognata to build simulation training for our AI based off specific training needs. We would use simulations with our specific target audience of bicyclists and even motorcyclists who move in similar way as bicyclists and are recommended the same safety hand signals. So how can we translate and create an intuitive experience for Chicago cyclists riding and navigating the streets with autonomous CTA buses? We come back to that second nature of a glance and a wave. The autonomous bus with its training has a prediction model of where bicyclists are going to go, but the bicyclists have no idea what the autonomous bus is going to do. So how do we create that confidence-inducing interaction design? This is how. One part of that experience is intelligent live pedestrian tracking lights on all sides of the bus. They cluster near the location of the human agent and they dissipate when they leave. The bus will show its AI pedestrian prediction travel path with an advanced puddle light of where it believes the bicyclist is going to go.
Here is a 360 view of the bus. The live intelligent tracking confidence lights that's displayed on the bus is shown to the bicyclist. It represents the glance and eye contact that we're looking for. The red, green, and yellow lights are the predicted travel paths, which is the hand gesture to motion to wave to a bicyclist for crossing or waiting. Here's an AV bus and bicyclist approaching a traffic light. The bicyclist wants to make an unsafe maneuver by turning left and crossing in front of the bus. The bus sees what the rider is doing. It doesn't think it's safe, but it acknowledges the bicyclist's intentions and then shows the predictive path. If the bicyclist was in immediate danger, the bus would stop for their safety. The future steps that we'd like to explore are adding confidence images, which shows traffic symbols for accessibility design, and also adding audio and sound. The trend of future cars is by going electric, which needs the sound of a motor for accessibility as well. And third is adding smart lane markers. It's for help separating the lanes on the road when the lane color fades due to heavy usage. This could be an indirect green solution. And also adding a predictive path, which is a long path stretch instead of just using spotlights. And finally, a smart interconnected infrastructure. This could work with technology like Bluetooth to work with autonomous vehicles and other pedestrian communications.
So building confidence would also be done via a knowledge campaign to the public. There would be a social media and poster campaign throughout the city to teach the residents the language of the autonomous buses coming into our community. AI predicts, UX makes it usable, Avai. Thank you.
Thank you. That's hugely exciting. I really like the proposal of having the bus do the projection, right? I think that's a really innovative idea, and I think I would push you to instead of actually have the path, just project a lane, right? Imagine if you just project the bike lane itself. I think there's a lot there, and there's precedent, right? Like if you think about the stop signs on the side of school buses, right? That's a sort of similar kind of piece of infrastructure, in that you're bringing the infrastructure into the interactive things itself. I'm also obviously particularly delighted to see this as an implementation of that heuristic of being able to predict and forecast, right? So that's lovely, and I might point to it in future talks as an example of how to do this right. And I think that's
as long as you give us credit.
Absolutely. One of the questions that I like here is your engagement with this notion of sort of speculative design, right? In that you're doing things that are tricky and are difficult and are somehow limited by contemporary infrastructure, but at the same time, you're predicting some stuff about the future that you're positing, you're positing a world that is possible, right? And to me, that's like the job of the designer, is to posit a future world and talk about the steps that would be necessary to get there. One of the questions that I have for the team as a whole is, what about the interaction with the infrastructure that is already there, right? So the two examples, whenever anyone does bicycle work, they always point to the Netherlands, right? And one of the things that's distinct, I don't know if you spent any time in the Netherlands, is that car and bus infrastructure and bike infrastructure are physically separated, right? Crossing the road as a pedestrian is incredibly hard because you've got to look left and right like 4 different times to get across the road, because everyone has their own spaces, right? Which is a super thing. So the question that I have for you is, what would it mean to take this stuff? And I think you implied it just at the end there when you talked about smart lane markers. But if you were to push beyond the current thing that you have there and think about the future of this as something that would be distributed not just sort of within the confines of a bus, but what would it mean to take this work and rethink the public utility infrastructure of Chicago even bigger than you've done so here?
So
again, a nice easy question for you, right? Softball, really.
Not a problem. I love that you asked this question, because there is a lot of research done with the infrastructure, specifically in inclement areas within the United States for autonomous vehicles. This is one of the biggest challenges that they have. Specifically, my Chicago dwellers know that streets are awful. There's potholes. They're always under construction. So being able to train the AI to read any of the street markers is very difficult. And this is a current challenge right now, which is why we're also saying this is part of the speculative, because in order for this to truly work, our entire infrastructure needs to have an upgrade. So from ground up, we need to look at everything. And when that happens in the future, hopefully soon, we would like to see very much an integrated system between public vehicles as well as personal vehicles and pedestrians. And there's conversations, and we briefly went down a rabbit hole of looking at devices that could attach to bikes. This was one of our earlier pivots, and where we pivoted to looking at Divvy, which is a rental bike in Chicago. So instead of having Chicago residents get these little devices to put on their bike to talk to the buses, it was then we pivoted and looked like, what's something that someone already uses that they rent and just can get on and go? Divvy. And that's how we landed with that. So that was kind of a loopy answer, but I hope I got it for you.
No, I think that was super. And again, I like that you've picked a solution that is the most actionable right, within the set of parameters that you've set up for yourself. And I think that's really nice to see. I'd like to correct Andrew, by the way. I can't see where you are in the chat. As I'm sure you're about to find out, it is often both winter and construction at the same time in Chicago.
Yes.
So you've got that to look forward to, right? But thank you. Nice project. Really nice.
Bring it on. Bring it on.
Yeah, congratulations, Abai. What a great presentation. It's so fascinating to think about, especially as we move forward and thinking about where we can go. You have me thinking now. So it is 5 minutes past our time. I'm happy to open it to one more question if we'd like to, but I do want to be conscious of our time here tonight and not keep everyone too long. And I want to thank everyone again for coming, and thank you to our students, Jofish, and our donors. It has been such a fantastic evening of listening and learning and discussing.